Hello everyone, myself K. Niranjana from 2nd year CSCB. Today I am going to present a topic about operating system structure. First, we discuss about the introductions of operating system. An operating system is a system software that manages hardware and software resources. It acts as an interface between the users and the hardware. It enables the users to run programs and manage files. Why is OS structure is important? The structure of an OS determines how its components interact and perform tasks. It affects system performance, security, and years of maintenance. Different OS structures are designed to optimize the speed, modularity, and reliability. And next, OS structure overview. The OS structure defines how the OS is designed and organized. It impacts performance, security, and system flexibility. There are 5 major types of OS structure: monolithic system, layered approach, microkernel system, modulator system, and hybrid system. These are the 5 structures of OS. And next, let's see the OS component. The operating system consists of several key components: kernel, user interface, system calls, device drivers. First, kernel, the core part of the OS that manages system resources. It handles memory, CPU scheduling, and device management. And next, user interface. It allows users to interact with the OS. There are 2 types: command line interface, graphical user interface. First, command line interface. For example, Linux terminal. In graphical user interface, for example, Windows and Mac OS. And next, system call. Act as a bridge between user applications and the OS, and it enables the program to request a service from the OS. And last, device drivers, software that allows the OS to communicate with hardware. For example, a printer driver helps the OS send print commands. These are the OS components. There are 5 components: monolithic system, layered approach, microkernel system, modular system, and hybrid system. First, we discuss about monolithic system. Definition is a single large program where all the OS service run in kernel mode. There are 2 features. First one, fast execution due to direct communication between the OS component. It is difficult to modify and debug because all services are in one program. For example, Linux, Unix, and Mac OS and MS DOS. These are the examples of monolithic system. Next, see the diagram of the monolithic system. Applications. There are 3 applications. And last, hardware. In monolithic kernel, there are file systems, network subsystem, memory management, process management, and drivers. The 3 applications are unprivileged mode, and down the monolithic kernel are privileged mode. Next, we discuss about the layer section. The OS is divided into layers, where each layer provides service to the one above. There are 2 features: modular and easy to maintain. Each layer only interact with the adjacent layer. For example, the operating system window NT. Advantages: easier to debug and update. It increases the system security by isolating the function. In disadvantages, can be less efficient due to extra overhead in layer communication. And next, see the diagram of the layer section. In down, layer 0 hardware, and up layer 1 and layer n etc. user interface. The layer looks like a circle. And next, the microkernel section. The definition is only the essential OS service like memory management, process scheduling. Only essential OS services like memory management, process scheduling run in the kernel. The features of the microkernel structure is increase the security, stability, because most services run in user spaces. Slower executions due to the message passing between the kernel and user service. For example, Mac OS, Linux. Advantages of the microkernel: structure is more secure because only a small part of the OS runs in the kernel. It is easier to extend and modify without accepting or affecting the core OS. Disadvantages: the lower performance due to message passing overhead. And see the diagram of the microkernel section. In upper part there are applications, in lower hardware, in upside basic IPC virtual module scheduling, in the tab 2 upside application IPS, IPC, Unix server, device drivers and file server. These four are connected to the applications. And next we see the modular structure. The OS functionality are implemented as independent module that can be loaded or unlocked dynamically. Features of the modular structure is flexible and extendable. Each module performs a specific task without affecting others. For example, Solaris and Linux kernel modules. Advantages: can add or remove the features without modifying the entire OS. It is easier to maintain and upgrade. Disadvantages: can introduce the compatibility issues if modules are not properly managed. And see the diagram of the modular system. Loadable module is in left side. In a connect to the kernel mode. It connects to the can call. And next the hybrid system. In hybrid system, the definition is a combination of multiple OS textures to improve the performance and flexibility. This is the definitions of the hybrid system in the OS. The features is it use both the monolithic and microkernel approach. It balances speed, modularity and security. For example, Windows, Mac OS and Android. Disadvantages are more complex to design and maintain. In advantages, it has two advantages: offers high performance, flexibility. It uses the best features of different OS architecture. These are the informations about the hybrid system. And see the diagram of the hybrid. There are two modes: user mode and kernel mode. In user mode, process management, file servers, input output management, memory management are present. In kernel mode, device drivers, low level address, low level process and inter-processor communication are connected. In down, hardware. And next we see the OS structure. Performance requirements are speed versus security. In modularity needs flexibility and years of updates. In next use case, embedded system, general purpose OS and real-time OS. And next we see the real-world application in OS system structure. Monolithic OS is used in earlier Unix-based system. In microkernel OS, it is found in embedded and real-time application. In modular OS, Linux supports dynamic module loading. In hybrid OS, Windows and Mac OS combine the multiple structures. The key features are the OS structure is system complexity, performance needs and security and reliability. In system complexity, the more complex system require modular and flexible structures. Next, perform needs. Real-time and embedded systems need high performance and low latency. In security and reliability, microkernels provide high security and fault isolations. And last, the conclusions of the OS system structure is the OS structures plays a crucial role in efficiency, security and flexibility. Each structure has advantages and limitations. And next, modern OS designs often combine multiple structures for both performance. Thank you.